All right, I've started the recording, so let's get going here with week 3 of information literacy. So as usual, I have a lot of information to share, and I will try to get through it in a timely way. I'm always plagued with trying to narrow down the scope of what I want to talk about to keep it to a reasonable amount, and remembering that not everybody is as excited about some of this stuff as I am. So, please feel free to speak up as I go if you have questions and comments and discussion. I do want to hear from you. This week we are talking about doing your own research. So last week we talked about the changing nature of media and some of the factors that are influencing it. We talked about some techniques that you can use to identify fake news, including some of the fact-checking resources that are available out there, as well as the CRAP test that you can use when you're looking at an individual site or resource. And we talked a little bit about some techniques you can use to get out of your own little filter bubble and get a more balanced view of the news. And we talked about some tools like spotthetroll.org, the Pro-Truth Pledge, things that sort of get people thinking in advance about how to identify fake news and how to combat it. So this week we're going to step away from the news a little bit, and we're going to step away a little bit more from social media as well, and we're going to talk about research, both academic and personal research. So this is one of my favorite little memes from the internet. YouTube is not research, so we will talk about what is research and how you can evaluate some of the things that are out there. So as usual, we have some ground rules. No problems here so far. This is my weekly reminder that if you don't want to be captured on the recording for this class, turn your video camera off before you ask a question or use the chat feature. And Wendy will keep an eye on that for me in case there are any chat questions coming in. So why are we talking about this? Well, it's a pet peeve of mine. You'll see this a lot, especially from conspiracy theorists online. Do your research, they will say. I've done my research. You're entitled to your opinion, but I've done my research. Now, they're not talking about real research, obviously. They're talking about looking at websites that are highly skewed towards their perspective. They're talking about watching YouTube videos. And remember that anyone can be a YouTube presenter. So you're going to hear this refrain from people all the time if you are engaging in conversation online. And it's common among anti-vaxxers, people who think about big pharma as a conspiracy out to get us, climate change deniers, QAnon conspiracy theorists. All these people think that they have discovered some kind of research that you just don't have access to, and that's how they are so much smarter than you. Of course, we know that that's not generally the case. They're not using good resources, so they don't even know what good research looks like. So here's an example, which may or may not be real, but it's kind of typical of what you'll see online. This was a discussion about medications used to treat ADHD in children, and someone talking about how bad it is that children are prescribed anything at all, and accusing the other person of not understanding the research. And of course, the person that they're talking with has a master's degree in neurobiology. So again, it goes back to this trend that we've been seeing, this distrust of information, this distrust of experts online. And a lot of that has to do with not really understanding how science works and how publication of that science works. So that's really what we're going to talk a lot about today. So let's get started. So let's go back to your middle school or your high school science class and talk about the scientific method. The idea behind the scientific method really has not changed since about the 17th century. And it is a continual cycle of observation, questioning what you're observing, forming a hypothesis about those questions, doing experiments to either prove or disprove those hypotheses, analyzing the results of your experience and your experiments, and coming to some conclusions about them. And I like this graphic in particular because it really shows how it's a cyclical process. It really never stops. A researcher is going to conduct an experiment and learn from it and then use that information to feed their next research. And other researchers are going to get that information through academic publishing and use it to fuel their research as well. So it is supposed to be a neutral process in which scientists look impartially for answers to questions. They form hypotheses and then they neutrally examine whether or not the experiment has proved or disproved those hypotheses, or really made no comment on that hypothesis. Of course, we're all human. Scientists are human. There are factors that affect how neutral we can be in this process. But this is the core of what science is supposed to be about. And again, this cyclical process shows you how science changes all the time. It evaluates new information and it uses it to revise those conclusions that it's made in past experiments, from past experiments. So when we talk with some frustration about how, 5 years ago they told me coffee was terrible for me and now they tell me I should drink coffee every day. What's the deal with that? Well, that's the scientific method in some part. We're testing new hypotheses and getting new data on things all the time, and we're revising our recommendations to people based on that new data. We're going to talk a little bit later about some of the problems that crop up in this process and how some of that is error in some way, but I'll leave that aside for just a minute. So just because science changes its opinion about something doesn't mean that it was wrong in the first place. It may just mean that we have new information right now. So talking about the two main types of research, of course, there are nuances, and this is like a fuzzy line in between the two. Things blend all the time. But basically, you can sort of consider there being two types of research. Academic research, whose goal is really just to expand knowledge, and applied or professional research, which has the goal of solving specific problems or perhaps developing new products or services in the business setting. So academic research tends to be more theoretical, and applied research tends to be more organizationally focused. It's more addressing a specific problem that a business has identified, either a problem within their own workflows or a problem in the greater world that they may be able to address with some solution that they can then monetize. So academic results are almost always made public through scholarly journals and publications. Applied research is not often published. Some of it is, of course. Some of it has to go through, for example, drug trials have to go through an FDA review process during which they submit that information. So some of that does become public through that process. But in general, applied research is kept within an organization, or it might be shared just within its own profession, professional conferences or trade publication, things like that. Academic research, on the other hand, is the goal for most academics is to publish and to make their findings public in scholarly journals and publications so that it can be assessed by other scholars. So again, fuzzy line, right? So if you have a federally funded research project that's examining a new medication, for example, is that applied? Is it academic? It's a blurry line. So let's look again at the medical examples. So the kind of basic research that we talk about on the academic side would be asking questions about how fundamental life processes work. How does disease occur and how can it be treated? Population-based research. So how do diet, genetics, or lifestyle influence the risk of disease? You're going to see a lot of that type of research being done on an academic side. You're also going to be seeing some of it done on a clinical or applied side. So a hospital may want to examine wide amounts of data in order to determine whether or not its practices in treating a specific disease are effective or not. And it may use that information to revise its own course of treatment recommendations for its doctors and medical professionals. So again, it goes back and forth quite a bit. But there's no question, no matter where those lines lie, that research is big business. $548 billion were spent on United States research and development in 2017. And this is data from the National Science Foundation. And according to them, 73% of that research was performed by businesses and only 13% by higher education institutions. The remainder might have been done by nonprofits or NGOs, things like that. Only about 17% of that was what we would consider basic research, just asking questions for the sake of better understanding the world. 80% of that would be considered applied research or experimental development. And it is largely funded by the business sector. So we have this impression that research is funded by universities or by the government, and it's really not. It's funded by the business sector. Sometimes the business sector funds it for their own in-house researchers to be doing that work. Sometimes they fund studies that are happening at other places like universities. But overall, the driving dollars in the research industry in the United States is from business. The federal government plays a large role in that as well. And then academic and nonprofit institutions kind of make up the rest. So it's sort of important to just understand where the funding comes from for this research so that you can know again, how it's being done. And you would want, of course, if you have a bit of research that was funded by a business, you would want to be aware of that so you could be aware of any potential conflicts of interest or influence over the end results for that. The report from the National Science Foundation is linked at the bottom of the slide. It's kind of interesting if you're curious about the state of United States science and engineering. It's kind of a long report, but with a lot of interesting information in it. So for the purposes of the average person understanding some of this research that's going on, journalists often will use academic writing to inform their articles. And so this information on the slide comes from an article that was written for journalists, and it was talking about the different types of articles, scholarly articles, that journalists might encounter and want to use in their writing. So I thought it was kind of a good overview just to give you an idea of the different types of things that you might see as you're looking through scholarly publications on your own. So the first type of articles you might see are experimental or observational. This is what we think of as on-the-ground research. A scientist has done an experiment and they are reporting on the results of that experiment. It's considered a primary source because it's written by the scientist that actually did the work. And so it's sort of focused just on that work. There is a lot of motivation for academics to break their work up into what we call sort of minimal publishable pieces. So they may do one experiment and try to squeeze 5 or 6 articles out of it. So these types of articles may be very tightly focused around one area of their research. A data analysis article, on the other hand, is analyzing existing data sets. So this is someone who has taken data from like the census or from government health data or historical data, and they're using that to analyze and identify trends. Longitudinal studies are similar. They take those kinds of data sets, but they look at them over long periods of time to see what long-term effects are of different aspects that they are looking at. So whether it's the effect of preschool education on adult success, that would have to be a longitudinal study, looking at children who had quality preschool education and whether or not that affected, say, their earning potential as adults. That's kind of an example of what a longitudinal study might be. A meta-study would be something that examines the results and data from previous studies. So a meta-study would take individual experimental studies, those smaller papers, those smaller projects, and attempt to put that data together to identify larger patterns or the truth, if you will, about a particular question. Those are difficult to do only because data isn't always directly comparable, but they can also be very, very useful because when you're looking at an individual experiment, the effects in that particular experiment may lead you to believe one thing, but if you look at a large collection of experiments about a topic, you may identify trends that take you in a different direction. So those meta-studies can be really important in sort of identifying the underlying meaning of things. Survey-based research reports are not actually, they're not experiments, but they are reports of surveys that were done of the general population. And they can be useful, especially for journalists who want to identify public opinions or public trends on certain topics. Reports are another thing that journalists look to a lot. These would be things that are written by government committees or maybe nonprofits. They examine an issue from a certain point of view, so they're not always completely unbiased, but that's not a bad thing in all cases. It's just, again, important to understand where those reports are coming from, how they might have been funded, and what their ultimate goal of writing the report was. And then what we call papers aren't generally considered research, but they come from 1 or 2 researchers and they address a broader question within a field. So they're almost like opinion pieces of the scholarly world. It's a researcher or possibly a think tank or organization looking at wider trends in their industry and writing almost an opinion piece about it and trying to direct the future course of research or discovery on the topic. So from a journalist perspective, and I like this quote, so I brought it right up here, the greatest danger of using studies in journalism is oversimplifying the findings or misinterpreting them altogether. And I think we've all probably can think of some examples where someone has seen something or read something and just, thought that it was the be all and end all of that topic, and they didn't have to do any further searching because they already knew the answer. And maybe they didn't even really understand what that that paper was writing about. So it is really important to back up and think about how any piece of scholarly writing that you're looking at fits into the wider world of that field of study. So how do you know what of these things you're reading when you stumble on something or you're doing some research and you find a paper? Often it's written right in the title or the abstract of the paper. It will say that it's a data analysis, or it'll say that it's a review article, or it'll say that it's an experimental study. So just read carefully, first of all, to try to figure out what it is you're looking at and what perspective it's coming from. So I want to talk about the academic publishing process and how these articles and information get created. Academic publishing is focused on scholarly journals and to a certain extent books as well. So we're not talking about newspapers or trade magazines or popular writing here. We've talked about journalism for the last few weeks. So now what we're really focusing on is academic writing. And this is, I want to talk about this not just because I think it's fascinating, although I kind of do, but also because this is what we think of when we think about science advancing our understanding of the world. This is the process that academics use to gather and disseminate that data and really change our understanding of things. So it's helpful, I think, to understand how this stuff gets created and what factors go into it. I want to point out that there's an important factor that kind of, I don't want to say clouds, but does affect this process all the way down the line, and that is that academic publishing is how academics make their mark in the world. It's how they build their careers. It's how they build their curricula vitae. So that has a lot of pressure. It places a lot of pressure on academics to publish. And that can affect, first of all, the number of things that they publish. So I mentioned earlier about how there is a tendency to break your research down into sort of those minimum publishable pieces. So you'll get 5 or 6 articles out of a topic instead of just one. That affects sort of your overall picture of an experiment. If you're reading an article about an experiment and you think that's all there was to it, but really there were 4 or 5 other pieces that you haven't been able to read yet, that would change your view of how that experiment was conducted and what was all involved in it. But it also can lead to a pressure to publish that can lead some academics to sort of cherry pick their data to demonstrate something that is a little more noteworthy or impactful than it might have otherwise been. And it can also encourage academics to accept some of these pay-to-publish models that are changing the way academic publishing works. Some of it for good and some of it not so good. So we'll talk about that in a little bit. So if you are an academic, if you're a researcher in an academic institution, publishing is one of the biggest ways that you establish your role in the field, your importance to that field, and therefore, get some job security, maybe gain tenure, get those prime research assignments or grants funded. So this is a business as much as it is science. And that's just sort of background knowledge for you to think about while we're going through this whole thing. So how do we get from data in the lab to a published article, and how well does that process sort of distill the information into useful knowledge as opposed to just noise? Obviously, the first step is to do the research. And this, then think back to a few slides ago when we talked about the scientific process or the scientific method. Researchers are forming hypotheses and testing them. Designing a study is really the key. So in the academic world, researchers are supposed to be guided by advisors and mentors and bound by their institution's ethical guidelines. So you can't just design a research project in isolation. You really need to be connected to your field, to have mentors in your field, to help guide you in the right direction. So the design of research studies is a whole study in itself, right? You can't just say, I'm going to go out and collect some data and then see what it tells me. You really, if you're trying to answer a question or prove or disprove a hypothesis, you need to carefully design an experiment to do that. So again, the academic setting is supposed to be part of that process. The university setting, the academic advisor setting, all those things are supposed to help feed into the design of good research. And part of that has to take into account whether or not researchers are actually qualified and capable of taking on the task that they're trying to do. So people tend to bite off more than they chew. I had a high school student tell me about 6 months ago, right when we started this pandemic, she'd written a paper for high school about the pandemic and she understood everything about it, and so I should listen to her advice. She's not really qualified to give me medical advice, and you'll find all the time academics who want to take on more than they're really qualified to do, or want to take on more than they have the funding to capably do. So again, that goes back to the process that lives in their institution. Ethical guidelines from their university, guidance from their mentors and their advisors. And how long does research go on? It is enormously variable. So we talked about some longitudinal studies that track people over long periods of time to understand the effects of things. I was reading for book club last month. We read Robin Wall Kimmerer's book, Braiding Sweetgrass, and one of the chapters or essays in that book was about a study that they did of sweetgrass and whether or not harvesting sweetgrass affected the growth of the plant. And that study, that sounds like a simple question, but that study went on for years before they could make any kind of conclusions about whether or not harvesting that plant was having an effect. So how long a study lasts is very variable depending on what you're studying and what effects you're trying to figure out. And so then you have to ask yourself, is the data that you're collecting actually answering the question that you're setting out to answer? And I finally remembered that quote I couldn't remember last week: figures don't lie, but liars figure. You have to make sure that your process is not just sort of ginning up the data to try to make a case that it really doesn't make. So the process is different for each field. We could talk for probably months just about how research projects are designed. We don't really have time for that. But I just wanted you to be aware that just because someone has done a project or wants to do a project doesn't mean it's going to be effective. So you have to really kind of understand the context where it came from, the background of the researcher, the university, or the other organization that supported them in doing that research. So let's say the research got done. Next step then, of course, is to write up your results. And I talked a few minutes ago about the kind of articles that journalists look for. There are some common article types that you're going to see in scholarly publications. And here are some of them. So research articles, again, these are those articles that are focused on one bit of research. They're presenting that original research and they're talking about the experiment and the results that were done in a particular project. They tend to have a very common format. So they start with an abstract that sort of summarizes the whole paper. They have an introduction, which also often includes a brief literature review. So they'll talk about the background information that you might need to understand why they've taken on this research and how it fits into the wider context of the field. They talk about their research methods, their results, their discussion and conclusion, and then they always have to provide references for the work that they've done and the works that they've cited. Review articles are something that I want you to be aware of because they're really useful to people who are trying to get a broad overview on a topic. Review articles are not articles that are reporting on original research. What review articles are doing is summarizing the state of research on a topic. So the author of a review article will pull up a bunch of references about that topic, try to get a broad spectrum of all the things that are being talked about on that specific topic, try to find things that are current, and then summarize them in a review article. Those review articles can be really helpful in identifying trends in a field. They can also be, for the average user like you and me, they can be a great source of sort of getting up to speed on a topic. So if you don't know enough about something to really begin your research, finding a review article is a great way to get yourself a broad overview of it. It can also help identify some gaps in research. So if all of the review articles that this author is, all of the articles that this author is finding are leading towards one area of a field, that author may be able to say, look, I haven't found any research in the last 3, 4, 5 years about this question. And maybe that's a gap that someone should take on. So they are useful to the field as well as to beginners in the field. Systematic reviews are collecting secondary data. So they're looking at data from other studies and synthesizing those findings. These are often, you'll see them in fields of healthcare and public health and public policy because they will be able to sort of identify wider trends And sometimes they use what I mentioned earlier, those meta studies or meta-analysis, to statistically analyze the data coming from different studies so they can identify a bigger picture. Theoretical articles, these are articles that are written by people who are experts in their field, and they are introducing new concepts or frameworks or theories. They are not considered research articles, but they are really important to the field in that they can sort of direct new areas of study, or they can propose new areas of study to the people in that field. And then in any scholarly journal, you're likely to find some editorials or commentary or book reviews. Those are not what you would call a scholarly article, but they can be very useful towards finding other sources. So we'll talk about how you can follow those little webs of citations to find more information for yourself. So the researcher has done their research, they've written it up, they've decided what kind of scholarly article they're writing. Next, it's time to submit it to a journal. And this is a really tricky part for a researcher. You have to find a journal that'll accept you. You have to find one that's reputable. You want to find one that's not going to charge you too much money to publish. Yes, you may have to pay to publish your own article. You don't want someone who's going to want to demand complete ownership of your intellectual property. You want to retain some rights over it, et cetera, et cetera. So it's very complicated, particularly when you consider that there are hundreds, if not thousands, of scholarly journals actively publishing. In fact, I would say thousands. I don't know the overall number because it changes every day, but it's a lot. So there are different types of scholarly journals. Traditional journals are, I think, what most people would think of. You submit an article for consideration. The journal says, yeah, we love that. We'll take your article. And then they publish it, and the people who want to read it pay as subscribers. So universities subscribe to journals, or individuals subscribe, and that's how it all gets paid for. Most of what you would consider the big journals are still using this traditional format. So you don't have to pay to be published in the New England Journal of Medicine, for example, or Nature, or some of those bigger journals. They are traditional publishers. But there's an increasing movement towards open access articles. And what makes an article open access is that people who want to read it do not have to pay to read it. It's available freely to the public, usually through a website. It's not usually a print journal, it's usually online. And it's not free to have an indexed version of that journal. So you could go and read the journal itself, but if you want to look carefully, if you want to be able to search it or find citations in it, that's a whole other thing, and that's a whole other profit model for some database people. But open access journals in general are available to the public. And there are different types of open access journals. So the Platinum Open Access Journal is generally supported by an institution like a university or a society like a professional society or a field organization. And that makes them free for authors and for readers. So I could submit an article to a Platinum Open Access Journal. They could say, yep, this is great, we'll take it, and I don't have to pay anything, and it goes out and is available to readers. The Gold Open Access model is one that we see more and more frequently. And this is where the author has to pay to be published in the journal. It's becoming very common. And you pay a fee, sometimes thousands of dollars, $5,000 or $10,000, to be published in an article. Sometimes less, but more for the ones that are more well-known. And that journal then uses the funds that you pay to help pay for the traditional process of scholarly publishing, which includes the peer review process and editing and promotion and that sort of thing. Then there's the Green Open Access model, which isn't quite the same in that it's generally not a specific journal, but many universities, for example, will require their staff, their faculty and researchers to deposit a copy of their published works in the university repository. It's often supported by universities. And the Green Open Access model is free for others to read. Authors do not have to pay to put their works into it, but it's not really publishing. Those articles are getting actually published somewhere else, and the university is just sort of keeping copies of them as a record of the research that's been happening at their organizations. Preprints are another thing entirely. So what I've talked about so far are traditional and open access journals. The articles that appear in those generally go through an editorial process. They have to be accepted for publication, and then they go through peer review, which we'll talk about in a minute. Preprints, any user can submit an article and it gets only minimal screening. Basically, a preprint would say, is this in our field of study? If so, yeah, you can put it in our website. So there's no review of those. So you do need to be sort of careful. I'll give some examples of preprints later. The benefit of preprints for authors is that if they can't get published in another way, at least they can get their work out there in a preprint. The downside of that is that if they couldn't get published in another way, you have to ask yourself why. Was there something wrong with that article or with the research that was the source of that article that made it difficult to get it published? So preprints you have to take with some caution. Overlay journals take articles from preprints and other open access sources and then publish them later. So I've got a couple links on here of preprint examples, and I'll talk more about them in a little bit. So as you can see, this is complicated, right? There's not just one journal of medicine. There's not just one journal of library science. There are dozens or hundreds or thousands of each. And a researcher needs to do that legwork of figuring out where they can publish and what is going to be beneficial for them to publish in. They want to find a source that's reputable. They want it to look good on their resume. They don't want to fall prey to unscrupulous publishers. So it's a very complicated process. Library science professionals try to help this a little bit by offering some ways to evaluate journals. So there are periodical databases like Ulrich's Web, which gives you information about periodicals, how long they've been publishing, who publishes them, what types of information they offer, those sorts of things. An important measure in the academic world, and probably I would say people consider it more important than it actually should be, but it's something that's talked about a lot, and it's the impact factor, or a journal impact factor. And what that basically looks at is, in a journal, like again, let's pick on the New England Journal of Medicine. How many times do people cite articles from the New England Journal of Medicine? So if I'm a researcher and I'm doing more research in a field, am I finding articles in that journal to be useful and citing them as my sources? And the idea behind that is the more times other researchers cite you, the more valuable your research was to the wider field. So an impact factor is supposed to be a way to measure how good a quality the articles that a journal is publishing. So obviously the bigger the number, the better off you are. There are lots of questions about impact factors. I'm not going to get into the details. If you're a data wonk about library science stuff, it's kind of interesting. But basically the idea is that all journals are not equal, and that we would consider one measure of quality to be, do other researchers find your articles to be useful and helpful towards forwarding their line of research as well. So there are some resources that our authors can use directly called Think, Check, Submit, helping researchers decide where to submit their articles. The Directory of Open Access Journals provides access to high quality open access journals, so it's almost like a review of some of those open access journals. And those are particularly important because anybody can start a website. So I could start a journal tomorrow and throw up a website and try to get people to submit to me. So it is important to have some background information about these open access journals and where they're coming from. And then of course, general knowledge of the field and your advice from your mentors. If your research advisor says, I've never heard of that journal before and I'm in this field, that might be a clue for you that it might not be a legitimate journal. And I say all this because there are things that we call predatory journals. Jeffrey Beal was a librarian at the University of Colorado, Denver. He's no longer there for various reasons. But he started about a little more than 10 years ago now, I think, talking about predatory journals. Predatory journals are journals that are really just in it to get author submission fees. They'll tell an author, hey, we love your article. You just have to pay $5,000 to get it published in our open access journal and you'll be all set. And they're not upholding the standards that are supposed to be part of the editorial process of academic journals. They are a problem for lots of reasons. First of all, basically they're scams. They're bilking researchers out of money, out of their own pockets. They don't get paid by their universities to do this often. They have to pay this out of their own pocket to get published. So they're scams. And then also they have a real impact on the quality of science that's being done. So if the only place an article can get published is a predatory journal, should it even be published? If it was rejected by legitimate journals, there's probably a reason why. And so, you know, Jeffrey Beall's quote here about allowing for counterfeit science to parade as if it were authentic science is a really important one. It's sort of changing the landscape in terms of what is available out there to build on for future research, and also for people like us to try to read and make sense of topics. Jeffrey Beall actually saw a lot of personal effects to starting this list of predatory journals. He no longer updates it because he got so many legal and personal threats for doing it. His university was uncomfortable with him speaking out about this topic. Publishers obviously did not want to be on his predatory journal list. And he won't directly say that he was chased out of his job at the University of Colorado, but many people suspect that he was. And the reason is because journal publication is big, big, big business. Universities in particular literally spend millions of dollars to subscribe to journals every year. So there is a lot of money to be had by publishing a journal if you are not doing it ethically. So, and there is pushback against this too. Not everyone believes that what was on Beall's list of predatory journals were truly predatory. Not everyone believes that it's a big a problem as he did. So again, there's always debate in a topic, but I think it's important, you know, just for the average person to understand that these things exist and they are a topic of conversation. So, I've been talking for a long time. I'm going to pause for a second. Anybody have any questions or comments so far?
Yes, I was surprised that the authors don't get paid. Like if you submit to a regular magazine, you generally get paid something.
Right, you definitely do not get paid for doing scholarly publishing, and in many cases you have to pay to be published. The idea is, of course, that publication is part of your responsibility as an employee of a research institution, for example. So, you know, the argument is that you're paid by your institution to be doing this work, and this is how you prove your worth to keep doing it. But you do not get a direct pay check for writing in a scholarly journal.
And if you get published and you're in a scholarly journal, is the accessibility of the scholarly journal open to everyone, or is it just the scholars who subscribe?
And again, that depends exactly on the journal itself. So open access journals are available to the public, but many of the more respected journals are not. You have to subscribe. So if you're part of a research institution, you probably have access to those through your university library, but the average public does not. So that is an issue. And I'll talk a little bit, I think, in the future, later in this talk, about that. So during the administration of President Obama, he issued an executive order that requires any research funded by federal dollars to be made available to the public within 1 year of publication. So it can still be published in one of these traditional journals, but it later has to also be deposited into an open access repository so that the public can have access to it.
Oh, okay.
So there is a delay there. But that's only for federally funded research. If your research was funded by a grant from a business or an organization, or even from your university, that's not necessarily the case. So it could be locked behind a paywall where people can't really get to it.
Great. My profession, if you submit an article, a research project, it is only for the members.
Mm-hmm. Yep, that's a pretty common model. Okay, so let's talk about the editorial process in scholarly publishing. So as I said, you submit your article to be published, but you aren't automatically accepted. So there is an editorial process. So the first step of that is just an editor who says, yes, this meets my need for articles in this journal, or yes, it fits into the scope of this journal, so I want to accept it. And then the next stage is peer review. Peer review has been talked about a lot. It is not perfect, but it's kind of the best we have right now, so we'll talk a little bit about it. So peer review is the idea that the people who could best evaluate the quality of research in a field are others who are doing work in that same field. So there are different types. So for example, clinical peer review might be the review of a patient's medical record after a medical incident to see if the proper protocols and treatments were followed. That's not exactly what we're talking about here. What we're talking about here is scholarly peer review. And again, peer reviewers don't get paid. They are expected to contribute to the scholarship of their field. And one of the ways that they're expected to contribute, in addition to publishing in the field, is by doing peer review. So peer reviewers are volunteers. It's not a small job. People estimate it takes, depending on the article and the field, could take anywhere from 4 to 12 hours to review one article for a thorough peer review. So why do peer reviewers do it? Well, again, it's that resume building. It's providing that contribution to their field, and it's an expectation by the whatever organization employs them, the university or the research institution that employs them, expects them to be an active participant in their field, and peer review is one of the ways that they do it. So what do? They do not reproduce the research that was done in the article, that's talked about in the article. It's not a reproduction of that work. All they're doing is carefully reading the paper, essentially. And what they're looking for is whether or not, first of all, the background of the researcher seems legitimate, and they've done their due diligence in doing a literature review and understanding sort of the state of the field that they want to publish in. They're looking at the methods. They're looking at the hypothesis that the researcher proposed, and then they're looking at the research methods to say, does this make sense? Would the methods that they use actually address the question that they're trying to ask? And then they look to see if the appropriate conclusions have been drawn from the data that was presented. So there has to be a level of trust that the author of the article has presented the data without cherry picking it, has presented it honestly. And then they're looking, the peer reviewers are looking for sort of the logical flow of this research. Is it a well-designed study? Does it back up its conclusions with evidence from the results of the study, that sort of thing. So it's a big time commitment for peer reviewers to do this. Most peer reviewers volunteer to do a number of articles a year, usually less than 10. So it's a somewhat rigorous process, and typically an article will be peer reviewed by more than one reviewer. So it's not just one person's opinion about whether an article is legitimate, but it's not perfect. Flawed studies still get published. For example, Andrew Wakefield published in 1998 a study that indicated that the MMR vaccine caused autism. That published study did not get retracted for 12 years. It was published in The Lancet, which is a highly respected medical journal. And it wasn't until 2010, 12 years after it was published, that The Lancet retracted it. And the reason is because the author did not disclose, first of all, a lot of the data. He cherry-picked his data. He didn't disclose that he was specifically working for families whose initial premise was that their child's autism was caused by a vaccine. And so it was a really, really messed up study. And medicine has spent a lot of time and energy trying to reproduce that research, debunking that research. And it's taken a lot of years. It took a lot of years just to get the study retracted from the journal it was published in. And we all know that it is still, the issue that from that single article really still haunts us today in terms of the anti-vax movement. So peer review is not perfect. And basically it's because we're not actually trying to reproduce a study. We're just asking experts to look at a written up article and say, does it make sense? Is it a good design? Does it seem like it's testing what it set out to test? But it is still considered the gold standard in that we don't really have a better way of doing this. We can't just reproduce everybody's studies to know if they're true or not. So it's not foolproof, but it is much better than just accepting articles and throwing them in there based on the fact that the author is from a well-known university. There really needs to be some sort of editorial process. But back in the mid-2000s, scientists started talking about this reproducibility crisis. And in 2016, the journal Nature did a survey, and basically the idea here is that interviewed scientists, well, 70% of interviewed scientists said that they have tried and could not reproduce another scientist's work. So they wanted to reproduce it for the purposes of their own research, but when they tried to do it, they got different results. And more than 60% of respondents said that there are two factors, that pressure to publish and selective reporting. So again, it goes back to this, I have to publish to keep my job. If I want to publish, I have to have noteworthy data to show and research to show. And so these are those human factors that creep into academic publishing. 33% of respondents in 2016 said that their labs had added measures to improve reproducibility of their studies in the last 5 years. Something like another third also said that they already had measures in place in their labs to improve reproducibility. So some of the things that they do are including others in the research so that there's not just one person doing it, trying to set up clear record keeping for their research process and clear lab standards and procedures to follow so that when something does go wrong, they can look back and say, oh, I didn't follow this procedure, so now I'm going to have to redo that. So there are ways that scientists can address this issue. And this reproducibility problem, most scientists will not say to you that, they'll say that yes, this is a problem, but no, it doesn't mean that all of academic publishing is invalid. There are things to consider, and I thought this graph from Nature's article about this study that they did was kind of interesting about the factors that lead to irreproducible research. So that selective reporting and pressure to publish way up at the top, bad luck way at the bottom, because things can always just go wrong. So there are a lot of factors. The Center for Open Science is one organization that is trying to address this issue. So they are releasing information on culture change within academia and practices to help improve reproducibility of studies. So this again is sort of a current topic in the industry or in this field of study. And it's something to think about. So if one medical study shows you that taking vitamin D will make you live to be 120, but you can't find any other studies that say that, you have to start wondering why, and you have to start looking at the broader field of research. So I think this kind of just points to the idea that you shouldn't be relying on a single source for important information. So if you've made it through the study, the writing of your study, the submission of your article, the editorial process, the peer review process, now you're published. And now you hope that others cite your work so that you can make your mark in your field and keep your job or get tenure or whatever you're trying to do. So that's kind of the academic publishing process in a long nutshell. Any questions or more discussion about that? Okay, so that's all fine and dandy, but we're not researchers, right? Most of us in here are not going to go out and do academic research. So let's talk about doing our own research and why you shouldn't. I linked something there, an article about why you shouldn't, so that you could read that later if you'd like. Again, I'll be posting these slides. So there's this, like I started the whole lecture with, the popular call and online debate to do your own research. So the article that I've linked here about why you shouldn't basically says, you shouldn't because you're not an expert. Doing research is not watching YouTube videos. Doing research is not digging up websites that support your already preformed conclusion. Doing research is a rigorous process, and we do need to have despite all of the flaws and problems that there might be in the academic publishing world, there is a process and there are institutions that are dedicated to trying to make that process as reliable as it can be. So doing your own research, first of all, it's just sort of foolish for you to think that you know more than people who've studied a topic for their entire career. So this takes a little bit of, humble introspection about where you fit into the wider world of understanding. It's not to say that science is never wrong, and it's not to say that individuals have never figured out something that science has missed, but all the processes we've talked about so far today talk about how science can be self-correcting and encouraging you to study all the time. So what I'm talking about here is not doing your own empirical research, and it's not doing your own 6 hours of watching YouTube videos and considering yourself an expert. If you need to do research on a topic for legitimate reasons for yourself, like making medical decisions or voting decisions or business needs, you do want to have some tools that can give you the access to the information that you need that's not already influenced by your own hypothesis. So first, keep an eye out for that confirmation bias. You need to keep an open mind. We are not here to just go out and say, I already know X is true, so I'm going to go find a bunch of websites that agree with me and talk about how they think that X is true also. That's not research. That's conclusion shopping, as this meme says. And you can do that with some pretty insane hypotheses because you can find a website that says almost anything because anybody can publish a website. Anyone can publish a YouTube video. Anyone can dress up like a doctor in scrubs and pretend to be a medical expert when he or she is not. So don't go out conclusion shopping. What you need to do if you're actually researching a topic is use quality sources and keep your eyes and ears open for pseudoscience. So again, YouTube, not research. Use that CRAP test that we talked about: currency, relevance, authority, accuracy, and purpose. That works just as well on sort of academic research as it does on a website or an online resource. So examine your sources critically and keep an eye out for pseudoscience. So we've all seen pseudoscience. This used to be like your crazy uncle who wanted to tell you about how the Mayans invented cell phones and things like that. But we see this even more on the web now because anyone, again, can publish their own website and information. So this little fun graphic sort of gives you 5 things to keep an eye out for pseudoscience. One is the language that they use. Are they using precisely defined terms, or are they throwing together a bunch of random words like supernatural, holistic, quantum subluxations to talk about a topic? Using big words is a way to confuse people. Now, science uses big words, but science defines those big words and uses them precisely. So the language used is one sort of red flag for pseudoscience. Does the claim have evidence? Does it link to actual studies and publications about a topic? Or is it just making stuff up? Is it relying on nothing more than testimonials? My uncle took this pill and now he's cured. That's not science, that's an anecdote. And those are not the same things. And that is a big problem with people understanding the nature of individual stories versus large amounts of data to really understanding something. Advancements, so pseudoscience is not incorporating new ideas and discarding old ones. It tends to dig in. This is already the answer I know, and I'm going to keep talking about it forever. And then explanations. Science attempts to explain things. Pseudoscience just asks questions without answering them. How do we know? Do we really know? Have you ever heard? Scientists can't explain it. Those are the kind of language that you're going to see in pseudoscience. So this is the kind of stuff you're going to see in disreputable websites published by non-professionals, people who are basically just sharing their own unfounded opinions. So where do you go for the good stuff? And I'll try to make this quick because we're a little bit running out of time, but I am almost to the end of my talk. And I thought about making all of today examples of how to do searches. But what I really know is that the way that you approach searching about a topic is really dependent on what that topic is and what your goals are for searching that information. And so it's really hard for me to make one lesson about how to search the web or how to search academic resources and get the answers you need unless I really know your particular situation. So this is a great case for making a reference appointment with your librarian. This is what librarians do. I can guarantee you any librarian in any library would love it if you called them up and said, I need help working on BadgerLink. Can you show me how this works? I need to search this topic. We love that stuff. So that's my first bit of advice, is take advantage of the professionals you have available to you. That includes your public librarian. That includes librarians at the local tech colleges and community colleges. If you were to go to Nicolet's library right now and ask for help, they would help you because you live in their service area. Similarly, if you walk into a University of Wisconsin library, you have full access to all of the journals and subscriptions that that library has access to, as long as you're in the building. They won't give you access at home if you're not a student, but if you're in the building and you're a resident of Wisconsin, you can go and use those resources. So take advantage of those things. On this slide, I've linked a lot of resources that you can use to find reliable information. And all of these are live links, so if you can grab the slides off of the website later, you can click on them and get access to them. So ways to start, techniques for getting started on a topic. So let's say you don't know much about a topic and you're going to set aside what you do know because you're not going to fall prey to confirmation bias. You're trying to get an unbiased picture of what this topic is about. A great way to start really is just kind of general web sources and use overview things like Wikipedia. Wikipedia is actually a pretty darn good resource. And I could talk to you in detail about that. But it's not a scholarly resource, but it's a way to introduce you to the main concepts behind an idea. So it gives you an introduction, basically. If you use Google in incognito mode, or if you use DuckDuckGo, you're going to get a little bit less of skewed results based on what you've examined in the past. So if you use Google when you're signed into Google, you're going to keep getting the same kind of stuff over and over. So I recommend trying it in incognito mode or using DuckDuckGo to seek out sources that get you outside your own bubble. Books are also a great way to get an overview on a topic. Books can be very, very detailed. Academic books can publish current scholarly writing on a topic, but the kind of books that you find in public libraries, where you'll find those through our Merlin catalog, that's our library's catalog. WisCat is the state of Wisconsin catalog. That one includes public libraries all around the state and academic libraries, so the UW system and the technical college system. And then WorldCat is the worldwide library catalog, and that includes libraries all over the world. So the kind of books that you're going to find in those resources aren't, generally speaking, current scholarly publishing, although there is some stuff like that in there. But reading a book about a topic, because of the nature of book publishing, it's a little slower. It's going to give you more of a background in a topic. So if it's something you really don't know much about yet, reading a book is a great way to introduce yourself to it. And the reason it's important to introduce yourself to a topic is so that you can do better searching later. So you don't want to start out by not even understanding the language of something and try to jump right into a medical database to understand it. You need to give yourself some background at least. I'm not saying you have to read 100 books, but look at the Wikipedia article, try to find some general resources, give yourself a little bit of background information. BadgerLink is a collection of databases that are free to every state of Wisconsin resident. If you're in a library or if BadgerLink can determine that your IP address is coming from Wisconsin, you can get free direct access to BadgerLink. If you're on CenturyLink, their IP addresses are wonky. You often don't look like you're coming from Wisconsin, so you may have to log in with a public library card number. But if you do that, you can get access from home. And BadgerLink databases are great because they include a lot of EBSCO databases. EBSCO is one of the major publishing aggregators. Well, they're a publisher in themselves, but then they also aggregate their publications into databases that are searchable based on keyword, based on subject, based on author. You can follow citations through them to find new resources. So these databases are very well organized to help you accurately find what you're looking for. They're also hard to use. So they're not super user-friendly. You're not going to use a database effectively the same way you use Google effectively. So searching in a database is a little bit different skill. And again, this is a case where your librarian can help you, because we can help you find a specific database that addresses the topic you're looking at, because there are many databases in BadgerLink. Everything from newspapers to auto repair manuals to medical journals. So first you want to try to find a database that's addressing your topic, and then you need to start to learn how to use that particular database, because they all have their own quirks. And again, great case for talking with your librarian. Google Scholar is Google, but for scholarly publishing. And it's great. It can give you a lot of great access to articles that are current about a topic. The problem with Google Scholar a little bit is the lack of context. So you have to do the legwork. If you found an article and you don't recognize the journal title that it's published in, you have to do the legwork to figure out, is that a legitimate journal or not? Google Scholar provides some hints for you to do that. One of the things it tells you is how many others have cited that article. So again, that goes back to that citation analysis or the impact factor. Things that are cited more frequently tend to be more reliable resources. So there are ways you can start to learn how to use Google Scholar to find good quality resources. And the great thing about Google Scholar is that it really gets you almost instant access into the deeper world of scholarly publishing. You may not be able to directly find the article. You may only be able to find citations about the article, but I'll talk to you in a minute about how to find the articles if they're not freely available. There are also lots of open access journals. So I talked earlier about open access. These are the ones that you do not have to subscribe to. Anybody can get access to them. The directory of open access journals can lead you towards some good ones. Public Library of Science, PLOS, is a open access journal and a relatively high quality one. There are many, many others. So that directory of open access journals is a good place to start. If you're looking for a topic, that directory can help you find journals that publish on that topic and give you some context to know what the quality of those journals are. Preprints, again, we talked about preprints. Those are the ones where anybody can submit an article to a preprint. So these are not peer reviewed. They're not edited or judged in any way. They're just presented by their authors. That can be great to finding new scholarship about something, but you have to use it with caution because you don't know about the quality. And university repositories often contain copies of published works by people at their institutions. So I'll talk a little bit more about that in a minute. Another important resource are government resources. So Medline and PubMed are some of the best medical databases out there for finding access to new information. The National Science Foundation's Public Access Repository. This is, again, back to President Obama's executive order, making all federally funded research be publicly available. Things go to the Public Access Repository. It has a ton of great information. It's not always super easy to use because it's not indexed as well as some of these other databases are. But there are some databases that are available in BadgerLink that index some of these other publicly accessible journals. So there are multiple ways into these things. The best way to find articles relevant to your topic is to sort of follow along citations. So you need to think about searching not as a one-time process, but as an iterative process where you're building your own knowledge and then you're following down paths of new discovery. So you're starting with those overviews, looking at the Wikipedia article, you're reading books, you're educating yourself about the language that's used in that topic. And then that knowledge will help you start to do searches. And then the results of those searches will help you start to find more information, particularly in the citations of articles that you find helpful. So if you found an article that is exactly addressing the question that you're talking about, go down to the bottom to the references and see what its citations are and see what else might be relevant to you there. That's a great way to follow through the thread of a topic. It's also a great way to fall down into rabbit holes so you can get really sucked into doing all these citations. But they're great ways to find information. The last thing I want to say is that you shouldn't pay for this stuff because you have access to a library. So we cannot get everything in the world, but if you do a quick search and you need a specific article and you want to buy it from Taylor and Francis, for example, the publisher, They may charge you $50 or $60 or $70 to download a PDF copy. Don't do that unless you're really, really pressed for time. Don't do that. At least ask your library, because we can help you search. We can search through some of those BadgerLink databases. We can try to find other ways to might make that article available to you for free. And we can request articles through interlibrary loan. So I can send a request to UW-Madison's library and say, I need a copy of this article, please. And they will gladly provide it, usually within 24 to 48 hours, if it's in their resources. We cannot request 100 articles from the same journal, because now we're getting into some of those copyright restrictions. You know, if you really need that much of it, should you be subscribing? But if you just need an article or a couple of articles or half a dozen articles, interlibrary loan is the way to go. Failing that, try emailing the article author. Usually the article will identify their name and the institution they work for. A Google search will help you find them at that institution, and you can shoot them an email and say, hey, I really would like to see this. Could you send me a copy? And almost always they're going to say yes. Sometimes they're already on their websites, so you wouldn't even have to ask. You could just download a PDF right from their website. Do a Google search. Google Scholar sometimes, or just a plain old Google search may help you turn up a freely published version of that paper. There's a Chrome extension, so if you use the Chrome browser on your computer, there's an extension called Unpaywall. When you are looking at an article, it will pop up this little green unlocked symbol that says, I have found a copy of this article available for free somewhere else on the web. Click here and I'll take you to it. It's a great tool. So that is actually one of the easiest things you can do, is install that Unpaywall extension. And then, as I mentioned before, you can visit a university campus and use their library. Almost all universities, especially our UW system, will allow visitors in their library. You have to sign in and those sorts of things. You can't just walk in off the street and, you know, sit down at a computer. But if you sign in, you can use their library resources at no cost to you. There are less ethical ways of finding free articles online. So Sci-Hub is one of the better known. They basically share articles between academics who get access to them through their universities, and then they post them on Sci-Hub. So you can make requests in that way. I'm not recommending that. I just want you to be aware that they exist. There are always people who are working around copyright restrictions. The better way to go about getting these articles is through the things that are on this slide. And the first one is always, you know, ask me, ask your librarian. We are happy to find things for you. So that's the end. That is the end of what I wanted to talk about. Thank you. I just want to reiterate that I didn't take the time today to actually demonstrate any of these databases, but I'm happy to do that for anyone at any time. So if you want to know more about BadgerLink, you want to know more about a specific topic, journal, and how you can find access to it, give me a call or shoot me an email. We'll set up an appointment time to come and look at those things, because that is what we're all about. So thank you for sticking with me for 4 weeks. I've had fun preparing for this class and presenting it to you. I hope you've enjoyed it. I hope you've learned something. Last chance for questions or comments before I go here.
Thank you. It was very interesting.
Jan, you have to unmute yourself.
You are one of our most valuable resource assets ever.
Well, thank you. I'm glad you think so. I'm glad to be here, and I'm glad to serve as your resident smarty pants. So if you have things that pop up, don't hesitate to ask me. That's what we're here for at the library.
Thank you.
All right. Thank you, Teresa. That was great.
I just wanted to mention a story. You were talking about fact checking, and I know that Wendy remembers this, where I was on Facebook and there was a cute poem about a pandemic, and it was cited as coming from an author from the 1918 flu pandemic. And I passed it on and Wendy passed it on, and then somebody wrote back and said, I fact checked that, and that author actually was writing about the COVID-19. So a little egg on face there. We had to apologize but I guess it's, it's a lesson about fact checking.
Indeed. Yep. It happens to the best of us, doesn't it? If you are willing to own up to it and admit that you were wrong and, sort of issue a retraction on your Facebook page, that's a great step in the right direction, man, because first of all, it shows that you've learned from that experience. And then secondly, it sort of sets the tone for others. It's okay to make mistakes on this stuff and own up to it and then correct it later. And to use the tools that we've talked about in this class to help you determine whether that stuff is true or not. So if everybody was willing to own up when they made a mistake, we'd all be in much better shape.
Amen.
Yeah, I just wanted to mention something I was gonna say in one of the earlier classes, and Dick, you can fill in because it's really your story. When Dick was doing a blog way back when they were threatening to put the mine in the Pinocchio, when he would check who was looking at his blog, and at the time we didn't get it, there were a lot of Russians, which we thought was interesting. And that was, way before. I was what, 8-10 years ago? I don't know, something like that.
Mm-hmm. Yeah, that is interesting. And you can see that stuff when you have a website. You can see where your visitors are coming from. And yeah, that was quite a while back. So fascinating that was happening back then. And interesting to put it into context now, knowing more about what we know about Russian disinformation campaigns.
Oh, Wendy, that's interesting.
Go ahead, Dick.
Hello, am I there?
Yes.
One little last thing here. A lot of times when you're doing research on something, you can do direct interviews, with department heads at government departments or county board things, and there are some really good things online. And I don't have any of them in front of me because I just thought of it, on good interview techniques, which are really important. And I guess the main thing I remember from it is that the first thing you want to do is gain the trust of the person that you're interviewing, that you won't misquote them, or if you tell them this is off the record, that you maintain it off the record. So interview is a very important part of doing research.
Yeah, and some of the same techniques that apply to professional journalists apply to sort of citizen journalism, which is what we would call your blog back in the days of the mining proposals. You don't have to be a professional journalist to employ those tools, and you're going to have better success talking to people if you use those tools, responsibly. That's a really good suggestion, though, because as you say, a lot of these people are very willing to talk to you. They want the public to be informed about the work they do. They do work for us, right? And then open records laws are also an important tool if you want to know what's going on in a government organization. Almost everything is supposed to be available to you through open records requests. Sometimes those are more difficult than they ought to be, but they can be great sources of information.
Well, thank you. Thank you very much.
Excellent.
Well, thank you. I'm going to wrap it up now. This recording will be on the website. The links are active in here, so download a copy of the slides and keep using it. And don't hesitate to reach out when you have questions for me. Happy to help. Bye, everybody.
Bye. Thank you.
Bye, everyone, forever.
Oh, forever.
Oh.
Don't say that.